Alright, welcome back. It is time for Array-2. Let's get into it. This has quite a few problems left, but we're doing very good so far. We've done 8 sections. How many are there left? There are, what, 9 left, so we're almost halfway there. I would actually say more than halfway there because these remaining sections don't have as many problems. But Array-2 has a good mini. Let's go ahead and get started. It says these should take about one loop. So, not too hard, I hope. Okay, so we need to return the number of even ints in the given array. So go ahead and pause and try that. Alright, considering what we've been doing, especially since we just did the string 3 section, which was pretty difficult, this should be a piece of cake, hopefully. So for each number in the array, if it is even, so if in remainder 2 is 0, so if it has a remainder when dividing by 2, it has to be even. We're going to increment the count and then return the count when we're done. So yeah, I mean, nothing else to say here. Note the use of the enhanced for loop makes this one quite a bit easier. In general, when you don't care about the index of the element you're looking at, it's good to use an enhanced for loop, but if you need the index as well as the value, then of course you can't be using an enhanced for loop. If we wanted to not use an enhanced for loop here, here's how we would do it. We'd say for each index up until the length of the array, this is very much like a string, and then we just say if, instead of in, we'd say at the number at this index, the element at this index, mod2 is, sorry, remainder 2 is 0, then increment count. And that would be how we would do it without the enhanced for loop, but as you can see, the enhanced for loop is more concise and has no downsides, so good thing to use here. Given an array length 1 or more of ints, return the difference between the largest and smallest values in the array. Go ahead and pause and try this. Okay, so let's think about what we can do here. So, okay, so the array's length is 1 or more, so we don't care, we don't need to worry about empty arrays. So, finding the maximum or minimum of something in an array or any collection of items, and it doesn't have to be max min, just like literal int value. It could be maximum, minimum. Like let's say you have an array of people, and you need to find the person with the maximum weight, or the maximum height, or the minimum, minimum age, whatever. Um, so finding max and minimum of a bunch of things is very common thing you need to do in programming. So let's see how we could do that. Basically, we will use math.min and math.max in a second, but I'm first going to write a solution that does not use those. So basically, the strategy is we're going to loop through the array, and we're going to start out with some value as the max. Let's just set it equal to 0. We shouldn't actually do this, but it's just, to demonstrate. So we have some value that's going to store the maximum number in our array. And what we're going to do is we're going to loop through the array, and whenever we find a number that's bigger than the max, we're going to set the max equal to that number. And then by the time we've gone through the whole array, whatever the max variable stores will be the maximum number in our array. And then very similarly with the min, whenever we find a number smaller than the min, we're going to set the min equal to that number. So this begs the important question: what would be an appropriate value for the maximum and the minimum? And what you want to do is, if you want to find the maximum, you want to set the default value of max to be the smallest possible value that an int can be, right? Because whenever we find a number bigger than the max, we set max to that number, right? And we can't, like, 0 is not a reasonable thing to put for max, because what if the array contains only negative numbers, right? Then a maximum, we can't set the default value for max can't be 0, because the true maximum of the array is negative. So max should start out as the smallest possible number that an int can store. And so the way you get the smallest number, the smallest value an int can store, is you just do int.min value. And this number is about -2 billion. Ints can store only a finite range of values because computers have a finite amount of memory, right? So we can't store an infinitely big number. So there is a finite range of values. And for ints, it's about -2 billion to +2 billion. And so integer.min value gets exactly the minimum value, gives you the minimum value. And notice that this is not a function, it's not a method. Um, it's something else. It's called a constant. So classes, we've talked, I've alluded to them before. They can of course have functions, as we've seen. Like the math class has a bunch of functions, like math.min is a function. But they can also store constants, and this is a constant. You notice that I don't put like parentheses after it. It's not a function. This is just a constant, and usually constants are written in all caps using underscores to separate words. So yeah, this thing here is just a constant representing the minimum value you can have on an int, and then similarly integer.max value. And notice that the type int and the type integer are different things. Integer is just a class, has some useful methods, some useful methods and constants related to ints. Okay, so we have our default values for max and min, and here's what I'll do. I'll loop through each number in my array, and what I'll say is if this number is smaller than or let's do the max first. If this number is bigger than the max, then the max is going to now equal that number. And if this number is less than the min is now going to equal this number. And you could put an else if here, right? Because if it's greater than the max, then it's obviously not going to be less than the min. So you could put an else there if you wanted to. But anyway, now we have found the max and min, and it says return the difference between the largest and smallest values in the array. So we just need to return max minus min, and there you go. If you wanted to do this using math.max, there's another way to do that. So here's how we could do that. Instead of saying if n is greater than max, max equals n, an equivalent statement is max equals math.max, max, and n. So two different things with the same name. This thing I've highlighted is the function math.max, and then this thing is our variable, which is called max. So this will basically say the maximum of my current value and n is now going to be stored in max. Similarly, we can do min equals math.min, min, n. There you go. All right, that's how we could do that one. Now this one, since they did guarantee you that the array's length is at least 1, another valid solution, another reasonable way to do this would be to set the default values for min and max to be the first element in the array. And if you want to pause and think about why that will also always work no matter the input, you can think about that if you want to. But yeah, generally integer.min value, integer.max value are what we use because it will work for any input. So that is how we could do that one. Return the centered average of an array of ints, which we'll say is the mean average of the values, except ignoring the largest and smallest values in the array. If there are multiple copies of the smallest value, ignore just one copy, and likewise for the largest value. Use int division to produce the final average. You may assume that the array is length 3 or more. Okay, so quite a bit going on here. Go ahead and pause and try this. Okay, so we want to find the centered average. So what we're going to do is we're going to add up all the elements other than the max and min, and then divide by the number of elements, but not including the max and min. So in other words, the final thing we divide by is going to be nums.length minus 2, because we're taking out the smallest and biggest. So actually, since we need the smallest and biggest number, I'm just going to copy this code, because this code gets us the smallest and biggest number. So okay, so now I have access to the smallest and biggest number and largest number, and the way I can do this is all I need to do is I need to take the sum of my array. So I'll take the sum here. I'll just do this in the same loop as I'm doing the rest of this stuff. Sum plus equals n. So now I have the sum of the array, and what I'm going to do is I'm going to just say, okay, so the sum without the smallest and largest is going to be, I'm just going to subtract from the sum the smallest number and the largest number. And then all I need to do is I need to return the sum, right? To take an average, you take the sum of the things, divide by the number of things. So sum divided by nums.length minus 2, because I took out 2 elements from nums. Of course, I didn't actually take them out. I just subtracted them from the sum. And there you go. That's how we could do that one. If you wanted to make this more concise, you could subtract them both at once like that. And there you go. And of course, we could even, if you wanted to, do some minus min minus max here. Not min twice max. Yeah, and that's how we could do this. Now, I'm gonna, like I've done in the past, show you something but not really explain it. So one other way to find the minimum and maximum value of an array, and I'm actually going to go back to the previous problem to show you this, is to, let's do this here. Okay, let's put this in a comment. Okay, so one other way of finding the maximum value is to what I'm about to show you. So if you do arrays.streamNums.max.get as int, that will give you the maximum number in the array, and then the minimum number can be acquired by doing arrays.streamNums.min.get as int, and then return max minus min will complete this method here. So that's another way of doing it. If you'd like to look into this method, it is called arrays.stream, as you can tell. And we will do it, and I'll show you how to do it, or show you how to see it here. So it is this one right here. Arrays.stream takes an int array, as you can see here, and it returns an int stream. So if you want to look into this type as well, I would also suggest reading the stream, the documentation for the stream class as well. So, so this stream type as well. So if you'd like to go into that, you can, but this is another way of finding the max and min. Note that this will throw an exception and crash your program if the array is empty, but this array says that it is not. Okay, so these are good. Return the sum of the numbers in the array, returning 0 for an empty array, except that the number 13 is very unlucky, so it does not count, and the numbers that go immediately after 13 do not count. So, okay, sorry, numbers that come immediately after a 13 do not count. Okay, that's clearer. Okay, I just read it wrong. Go ahead and pause and try this. Okay, so we're going to take the sum, so I'm going to start sum out as 0, and basically we are going to need access to the indices, so we can't do a for and enhanced for. So I'm going to loop through my array, and so all I'm going to do is if the current number is a 13, so if nums I is a 13, or actually let's basically in this if statement I'm going to say if this number is eligible to be counted towards the sum, then count it towards the sum. That's what this if statement is going to say. So a number is eligible to be counted towards the sum if it is not 13, and the number before it is not 13. And notice that if an element is at the beginning of the array, then of course nothing comes before it. So, and either it's at the beginning of the array or the number before it is not 13. If those are both true, then we will count it, count this number towards the array. Sorry, towards the sum. And I meant to say I minus 1 here. And then just return the sum there, and that will do it. Return the sum of the numbers in the array, except ignore sections of numbers starting with a 6 and extending to the next 7. Every 6 will be followed by at least one 7. Return 0 for no numbers, which I think also includes an empty array. I'm just going to test and see. Okay, so yes, they do mean 0 for an empty array. All right, go ahead and pause and try this one. All right. Okay, let's do this one here. Okay, so ignore sections of numbers starting with a 6 and extending to the next 7. Every 6 will be followed by at least one 7. So let's think about how we could do this here. Okay, so I think I'm actually going to have to use a couple loops here. So let's basically do what we were doing on the string problems. Whenever we find a 6, we send out a scout to find the next 7. So in other words, in actual coding terms, we send out another index, to count up and find where the next 7 is. And then we just skip past all that range and then keep adding to the sum. So that's what I'm going to do. I'm going to start the sum out at 0 for each item, or for each index in the array. I'm going to loop through. And I don't know if I want to increment yet. I won't increment. So here's what we'll do. We'll say if numsI equals 6. Yeah, so if numsI equals 6, then we have stuff to do. Otherwise, I'm just going to write the else case because it's really easy. Otherwise, just add numsI to the sum, and then increment I. That's what we want to do otherwise. So if numsI equals 6, I'm going to create a scout, another index. I should actually stop saying scout and just say another index. Another index that's going to search for the next occurrence of a 7. So j is going to start at I plus 1. And it's going to go until we find a 7. So while j is in bounds, of course, and nums at j is not a 7. So yeah. So now j is going to be the index of the next 7. And in fact, we are guaranteed that every 6 is followed by at least one 7, so I do not need this. Because I know, actually, that that I will not be going out of the array, out of bounds of the array, because there will never be a situation where a 6 is not followed by a 7 somewhere later. Okay, so let's keep going. Okay, so now j has the index of 7, of where the 7 is. And now all I need to do is set I equal to j plus 1, because j is where the last 7 is, and I want to start right after that 7 and keep adding things to the sum. So now I just need to return sum. That's how we could do that one. And I'm noticing that I'm adding one here and I'm adding one here. So I'm actually just going to increment it. And instead of adding anything there, I'm just going to do that. And that'll do it as well. Yeah, I think that is all I have to say about this one. Let's keep going. Given an array of ints, return true if the array contains a 2 next to a 2 somewhere. Pause and try this. Okay, let's do it. This one's not too hard. We're just going to go through the array. So I'm going to see if at index I there is a 2 and that the next index is a 2. Sorry. And if I find that situation, then I've found a 2 next to a 2 somewhere. So I equals 0, I less than nums.length minus 1. I can't go right up to the end, right, because I'm going to be checking the thing at I and the next index. So if I'm at the end of the array, right, I can't go to the next index. I've said something along those lines like a dozen times so far. Okay, and then I'm going to increment. And so if nums I is a 2 and nums I plus 1 is a 2, return true. Because I've now found a 2 next to a 2 somewhere. Otherwise, if we get through this whole for loop without finding anything, return false. Given an array of ints, return true if the array contains no 1s and no 3s. Okay, so no 1s and no 3s. Pause and try this. Okay, so basically I'm going to do a helper method called contains no. So it's going to take a nums array, and then it's going to take a number x, and it's going to return true if the array does not contain x anywhere in it. And I'm assuming that if the array is empty, well, okay, no, I don't need to assume that. That's just obvious. If the array is empty, it does not contain x. Okay, so because I'm always aware, I'm always thinking about the edge cases, like the rare special cases. Okay, so for each number in my array. So if this number is x, so if I found an x in my array, then I should return false because it does not contain no occurrences of x. So I should return false, of course, if in equals x, I should return false. And then I should return true otherwise. If I go through the array and I don't find any x's, then we know that the array has no x's. Okay, so all I need to do is say return if the array contains no 1s and contains no 3s. Alright, there we go. given an array of ints, return true if the sum of all the 2's in the array is exactly 8. Pause and try this. Okay, so an equivalent way of saying this question is return true if there are 4 2's in the array. So I'm going to do that. So I'm going to say int count, which is going to be the number of 2's we found in the array. All I need to do is go through the array. If that number is 2, increment the count, and then I just return true if count equals 4. Nothing too challenging there. Given an array of ints, return true if the number the number of 1's greater. Wait, sorry, I'm reading this wrong. Given an array of ints, return true if the number of 1's is greater than the number of 4's. Go ahead and pause and try this. Okay, so number of 1's greater than the number of 4's. Okay, so guess what I'm going to do? I'm going to make a helper method. It says count. It's going to count the number of times x occurs in nums. So what I'm going to do is I'm going to say for int in colon nums, and I want to make a counter as well. For each number in the nums array, if I found an x, increment the count, and then return the count. And all I need to do is say return the number of 1's is greater than the number of 4's. All right, there you go. So for this one, there is actually a sort of sneaky way to do it. Well, not sneaky, but there is a way to do it using the int stream stuff I talked about before. So again, I'm not going to explain this. I'm just going to give the solution to you if you want to look into it on your own. So another way of writing this count method is to say arrays.stream nums.filter in equals x dot count, and then we're going to need to cast this to an int because the count method returns a long, and that's another way of doing it. All right, given a number in, create and return a new int array of length n containing the numbers 0, 1 to to n minus 1. The given in may be 0, in which case return an empty array. You do not need a separate if-else statement for the like 0 case. Okay, they're kind of micromanaging you here on the coding, but go ahead and pause and try this. All right, so we can totally do this. So our array, int array nums, is going to have length in, and then this is really a very straightforward problem. I just need to assign, basically I'm assigning the value at every index to its index. So ls the nums.length. All I need to do is say nums I equals I, and then return nums, a very straightforward one here. Yeah, I think there's actually a method in the arrays class that might help us here. Let's see. There is, and actually it is old enough that CodingBat will know what it is. So there's actually another method we could use here if we wanted to. We could do arrays.setAll nums in and set each number to or set each value to itself. Okay, that would do it. Okay, so basically what this is doing is it's just taking for the array, it's setting, given the index of the array. This thing I highlighted is the index, the index of a spot in the array. And basically this thing is like a mapping that maps this in a certain index to the value that I want to put at that index. And so I'm just mapping I to I because the index is the value. This thing here is called a lambda expression. I'm not going to explain them here. I'm just giving you alternate solutions at this point. You can look into these things if you want to, but I always want to give you different solutions. And in fact, I believe we might even be able to do this in yet another way by doing intStream.range 0 to n.toArray. And I think it's not going to know what I mean because I'm going to need to import this, or not import, but give it its full name. And so that is another way of doing it or in a very concise manner. Again, you are free to look into that if you want to. Given an array of ints, return true if every element is a 1 or a 4. Pause and try this. Alright, so basically I'm going to loop through, and if I find something that's not a 1 or a 4, then I'm going to return false. So for int in :nums, if n is if n is not a 1, and it's not a 4, then it must not be a 1 or a 4, and I should return false. Okay, and then otherwise, return true. Okay, so a lot of array problems, but they're not really that bad on their own. Okay, and then I'll show you another way to do it that you're free to look into if you want. Another way to do it would be to do arrays.stream nums.allMatch. All numbers are a 1 or a 4. Another way to do it. Given a number n, create and return a new string array of length n. Containing the strings 0, 1, 2 through n-1. N may be 0, in which case just return a length 0 array. Note string of value of will make the string form of most types, which you already know. Okay, go ahead and pause and try this. Alright, hopefully this one was not too difficult. String array strs, I'll just call it strs, I'll call it R for array. Is going to be an array of length n, and all I need to do is say for int I equals 0, I less than n, I guess I can do I++, and I just need to say r, I. Notice I could have put I could have put r.length or n here, but I know r.length is n, so either one's fine. All I need to do is say ri is the string form of its index, and then return my array. Right, yeah. Okay, so let's see. I need to do that. Okay, so that's how we could do this one. If you wanted some alternate solutions, I will give you those. So another way of doing this is to use the setAll method again. Oops. And basically say arrays.set all r, and then for each index, what I'm going to put at each index is the string form of that index, and then return my array. So that's another way of doing it. Yet another way of doing it is to do return int stream dot range 0 to n dot map to obj. I'm going to put this onto a new line, map to obj, I to the string form of its index. Map each number to its string form, and then make this to an array. And I believe I'm going to need to specify the type of the array there. And so that is another way of doing it. That one's actually in one statement. Okay, so yeah, there's a lot to Java. There's a lot of useful things here, which you're welcome to look into. Okay. Given an array of ints, return true if it contains no 1s or it contains no 4s. I'm starting to have deja vu. We've done a lot of problems like this. Pause and try this. Oh wow, you could hear me cracking my knuckles on the microphone. Okay, so, or I think you could. Okay, so no 1s or no 4s. So I'm gonna do, yeah, I really have done this one before. I don't know. I can type fast enough. I don't need to go find the code and copy it. So I'm gonna make a boolean that it contains no occurrences of a number. So this method's gonna return true if nums does not contain an x, which means that if it does contain an x, then it does not contain no x's, and then otherwise return true, and then I need to return if this contains, just trying to get the indentation right, contains no 1s or it contains no 4s. There we go. we'll say that a value is everywhere in an array. For every pair of adjacent elements in the array, at least one of the pair is that value. Return true if the given value is everywhere in the array. Pause and try it. All right. Okay, so yeah, so I'm pretty much gonna do this exactly in the manner they described in the problem. Yeah, so I'm basically just gonna loop through the array and go through each index and say, is either this index or the one after it equal to val? And I'm actually gonna change this to in. Okay, so for each number in the array, and I'm gonna stop one before the end. Hopefully you can see why. Sorry, yeah, one before the end. Okay, so if, I suppose I don't need this, if nums I, so I'm actually going to ask if neither of these guys are in, then I know in is not everywhere in the array, and I'm going to return false. So if this one is not in, and the next one is not in, then in is not everywhere. Otherwise, it is. There we go. Yeah, I'll show you another way to do this. This is a sort of convoluted way to do it that you can look into on your own. So we could do this here. We could say range 0 to nums.length minus 1, and then dot all match nums I equals in, or nums I plus 1 equals in. Another way to do it. Given an array of ints, return true if the array contains a 2 next to a 2 somewhere, or a 4 next to a 4. Oh, sorry. If the array contains a 2 next to a 2, or a 4 next to a 4. Okay. Pause and try this. Okay, so I'm going to do a helper method that returns true, that takes a number x and returns true if the array contains an x next to an x somewhere. So x next to an x somewhere. Boolean next, next x, I'll call it int array nums int x for each number in the array, not including the last one. If this this number is x and the next number is x, then we have found an x next to an x, otherwise we have not. And then when it says, whenever you see A or B but not both, like you see in this problem statement, you should be thinking x or. So return if I contain a 2 next to a 2 somewhere, x or a 4 next to a 4 somewhere. And there we go. Given arrays nums1 and nums2 of the same length for every element in nums1, consider the corresponding element in nums2 at the same index. Return the count of the number of times that the two elements differ by 2 or less but are not equal. Pause and try this. Okay, so differ by 2 or less but are not equal. So I'm going to loop through the array. I could pick nums1.length or nums2.length. Doesn't matter because they have the same length. And all I need to do is say if they differ by 2 or more but are not equal. So what I'm going to do is I'm going to say the difference is going to be I'm going to use math.abs to find the difference. I'm going to say nums1 at this index minus nums2 at this index. And then the difference has to be 2 or less but not equal. So in other words, if this difference is 0, then they're equal. But if this difference is 1 or 2, then we're good. So if this difference is 1 or 2, I want to increment my count. And then when I'm done, return the count. And of course, declare the count at the beginning here, starting at 0. And so that is how we could do that one. By the way, a lot of these solutions can be done using the in-stream stuff I've been, sprinkling in here, but I'm only showing it for a couple of them. Given an array of ints, return true if the array contains two 7s next to each other, or there are two 7s separated by one element, such as with 7, 1, 7. Pause and try this. Okay, my strategy, Um, so a couple ways I could do this. I could split this up into two methods. One method takes, or one method determines if there are two sevens right next to each other. One method determines if there are two sevens separated by one element. And then just say, first method or second method. That's one way to do it. Another way to do it is combine them into like one loop. And I'm going to try that strategy. So I don't need an int count. I just need to return a Boolean. So basically, I'm going to go through the array. And for each index in the array, I'm going to ask, are there two sevens with the first one at this index? Or are there two sevens, are there two sevens, one at this index, one at the next index? Or are there two sevens, one at this index, one, two doors down? So that's how I'm going to do this one. I'm going to stop one before the end, but in order to check the case with one element in between the sevens, I'm actually going to need to make an extra check there. So I list the nums.length minus 1, and then what I'm going to do is I'm going to say, first of all, if the element here is a 7 and the next element, well, first of all, actually, I'll just check if the number here is a 7 and then enter an if statement, because that's going to be redundant, because in both cases, whether it's two sevens right next to each other or two sevens separated by one element, I still need the first element to be a 7. So this one's a 7, so I'm going to say if nums I plus 1, and I know I plus 1 is safe, like it's a safe thing to index because I know that I will never be the last valid index in the array. So if the next one's a 7, then return true. And uh, if we're not too close to the end, so if I is less than nums.length minus 2, so if we're not too close to the end, and I plus 2 is 7, then also that is grounds to return true, and if we don't find one of either of these cases, we return false. All right, there we go. If you really wanted to, I suppose you could put an else if there, and that means you could omit all of these curly braces. So, yeah. Okay, return true if there is a 1 in the array with a 2 somewhere later in the array. Okay, pause and try this. Okay, so if we had index of methods on arrays, this would actually be really simple, but we don't. So go ahead, or sorry, no, don't go ahead and pause and try this. You've already done that. What we should do is we should go ahead and we should, I'm trying to think. So basically, I'm going to use like the same idea as index of. I'm going to say, okay, where's the first 1 in the array, and then where's the last 2 in the array? And if, well, first of all, if there is a 1 in the array, and if the first 1, the index of the first 1 is less than the index of the second 2, or sorry, the last 2, then we're good to go. So I'm going to say index 1, which is going to be the index of the first index of a 1 in the array. And I'll set it equal to -1 by default, because like the index of method gives you -1 if it doesn't find the thing you're looking for. So I just go through my array, and what I do is I say if I find a number in my array, so if nums at index I equals a 1, then index 1 equals I. I'm going to put this in curly braces actually. Here. Okay, so if I found a 1, index 1 equals I. But I want to make sure that I find the first 1, right? And if I just let this loop run to the end, then this variable index 1 would actually hold the index of the last 1 in the array. Since I want it to find the first one, what I'm going to do is as soon as I find a 1 in my array, so the first time I find a 1 in my array, I'm going to get out of the loop. Like I'm going to stop searching, I'm going to stop looping. And the way we can do that is we can say break. This is a break statement. And basically, all this does is it breaks out of the loop. So whenever you see this, whenever the code reaches this point, it's going to break out of the innermost loop. So it's basically the loop's just going to end. No conditions are checked, nothing's incremented, nothing else is done. It's just just all the way breaks out of the loop. Okay, so now I have the index of the first one. Now, if this index is -1, then my array doesn't even contain a 1 anywhere. So I'm going to just return false right away, because I know I don't even have a 1 anywhere. Now I'm going to search for the last index of a 2. So it's going to be similar. What I'm going to do is, since I want the last index, I'm going to start at the end of the array. So I'm going to say I equals nums.length -1. I is greater than or equal to 0. And in fact, I could actually do I is greater than num index 1 if I really wanted to. I minus minus. Then I say if nums I is at 2. And actually, since I know I'm always going to be greater than index 1, what I can do is I can just say if I find a 2, I'm realizing now I don't even need the index 2. If I find a 2, I'm searching only in the area of the array that's greater than index 1, whose index is greater than index 1. If I find a 2 somewhere over here, then I can return true. And then if I get all the way down here, I should return false. So that's how we could do this one. And notice that I don't have to increment backwards. I was doing this because I thought I had to, but I don't have to. So you could also just increment forwards. And you could say I equals index 1 plus 1. You could start at index 1, but we know index 1 has a 1, so there's no reason to ask if it has a 2 because it has a 1, and we know that. So I can also do it this way, I less than nums dot length I plus plus. So I could do it this way here. Yeah. So of course there are other ways to do this, but I am happy with this way here. So let's move on. Actually, wait. I'm trying to think if there's a better way to do this. Or not a better way to do this, but there is a different way to do it that I think is worth showing. So I'm actually going to show you that. Okay, so here is an alternate way to do it. So one way to do it is say if we found a 1, so I'll just say found 1. This Boolean is going to be true if we found a 1 so far. We're going to look through the array. It's going to be true if we found a 1 so far, false if we haven't. So it's going to be false by default. What I'm going to do is I'm going to go through the array, and I'm going to say if this number is a 1, then if in is a 1, then we found a 1. And then if this number is a 2, and we've already found a 1, so if this number is a 2 and we found a 1 previously, then we actually know we've satisfied the problem. So that's going to be good. And then that's another way to do it that is more concise. So I actually quite like this way. I think it's better. So yeah, you could put an else if here because we know that if n equals 1, then obviously n is not going to equal 2. Or you could leave it like that, whichever way you want. And I personally think this way is better. So I'm glad I went back and showed you this. All right. Return true if the array contains either 3 even or 3 odd values, all next to each other. Go ahead and pause and try this. Okay, so 3 even or 3 odd values, all next to each other. Okay, so let's think how we could do this. Okay, so I'm just going to loop through the array and see if there are 3 even or 3 odd values starting at the index I'm looking at. So I'm going to go through the array, stop too short of the end. Length minus 2, okay, and then basically I'm going to make a Boolean for each number. So for the value at index I, at I plus 1, and at I plus 2. And that's going to be basically the Boolean will be true if it's even, false if it's odd. So basically just say I'll just call them ABC actually. So A will be if the value at I is even. B will be if the number at I plus 1 is even. 2. And C will be, I'll move C to the next line. C will be if nums I plus 2 is even. Okay, and so basically if they're all even or all odd, then A, B, and C are going to have the same value. A, B, and C are either all going to be true or all going to be false. So if A equals B and B equals C, then, so in other words, if they all have the same value, then I've found either 3 odds or 3 evens all at once. And in fact, at this point in my code, I don't even know. Like, this if statement doesn't care whether they're all even or all odd. It just cares that they're all the same. Parity. Parity means refers to whether or not a number's even or odd in math. So I believe it does. You might have to double check me on that. But if we go through and we don't find 3 evens or 3 odds in a row, then we return false. Okay, all next to each other. Okay, let's see. Interesting, so mine is running false here, and that's because I am not doing mod2, sorry, remainder 2 there. Okay, there we go. Return true if the value 3 appears in the array exactly 3 times and no 3's are next to each other. Alright, a couple conditions here. Pause and try this one. Okay, so I'm going to split it up because these conditions aren't exactly related to each other. So I don't think there's an advantage of like putting them in the same loop or same code. So if the value 3 appears in the array exactly 3 times, so count 3. So it'll take a number array, and what I'll do is I'll say int count equals 0. Hopefully you're starting to see that creating a counter and then checking a condition in an array is a very common thing to do in programming. So for each number in the array, sorry, give me 1 second here. Okay, so for each number in the array, we are going to, if this number is 3, return, not return, increment the count, and then return the count. And actually what I'm going to say is, I'm going to say has 3, 3. So 3 appears exactly 3 times. So if has 3 3's, so I can just say return count equals 3. So that's going to determine if my array, if 3 appears in the array exactly 3 times. And now I need to determine that no 3's in the array are next to each other. So all I need to do is for each index, make sure that that the index at, well, let's see. I need to make sure that it is not true that index I and I plus 1 are both 3. So, and then I'm going to say boolean no 3 next, enter items. Okay, so for each index in my array, stopping 1 short of the end, if this number is, let's see, so if this number is 3 and the next number is 3, so if I found 2 3's next to each other, then I return false. Otherwise, true. Then all I need to do is say return if I have 3 3's and I don't have 2 3's next to each other. Okay, and line 7, that's because I'm not saying equals 3 there. Okay, there we go. Return true if every 2 is next to another 2. Okay, pause and try this. Okay, so what I'm going to do is I'm going to go through the array and I'm going to see if the thing at index I is a 2, then is either its left or its right also a 2. If so, continue going, continue searching. If not, return false. So for int I equals 0, I'm going to go through the whole array here, but I'm going to have to do some special checks if I'm at the start or end. So what I want to do is I want to ask, is it true that at index I there is a 2 and there's no 2 next to it? So if nums I is a 2, and so there's no 2 to the left of index I, if I is 0 or nums I minus 1 is 2. And it is the case that there is no 2 to the right of index I if I is at the end of the array or the next number in the array is 2. Sorry, is is not 2 in both these cases, is what I meant to say. Okay, so if those things are found to be true, then we should return, false. Otherwise, we return true. So this basically is checking, is there any lone 2 in my array? Is there any 2 that does not have a 2 next to it? And if I find such a 2, I return false because it is not the case that every 2 that appears in the array is next to another 2. Otherwise, if I find no lone 2s, I return true. Okay, so return true if the group of in numbers at the start of the array and into the array are the same. For example, with 5, 6, 45, 99, 13, 5, 6, the ins are the same for n equals 0 and n equals 2, and false for n equals 1 and n equals 3. You may assume that n is in the range 0 to nums.length, inclusive. Go ahead and pause and try this one. Okay, so we don't have to do any bounds checking because we're guaranteed that n is in range. So here's what we'll do. So, okay, what I'll do is I'll go through and say, okay, so for int I equals 0, I less than n, so I'm going to check every index up to n, up to, wow, okay, I kind of feel like this problem could use some proofreading. Like, if you're going to say the group of n numbers, then maybe like the variable should be called n. Okay, so for each index up to n, what I'm going to do is I'm going to say, okay, is this number and the corresponding number at the end of the array, are they equal? So like, if I am doing this first one, or sorry, let's do this middle example, then, okay, so when I equals 0, I'm looking at this 5 versus this 5. When I equals 1, I'm looking at this 6 versus this 6. And so notice that when I is, well, okay, so let's say for any value of I, the corresponding number I want to be looking at is at index, let's see, nums.length minus n plus I minus 1, I think. So let's see, nums.length is 7 here. So 5, when I is 0, we want to compare it to 0, 1, 2, 3, 4, 5. So yeah, so nums.length minus n plus I minus 1. So if nums at index I, so if they don't match, I'm going to return false. So if nums at index I is not equal to nums at nums.length minus n plus I minus 1, if they're not equal, then I know that the range at the start and end of the array is not the same. So return false. And if I get through that, all good, return true. Okay, let's see, what have I done? False, 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 they're all false. Okay, what's going on here? Okay, so, wait, do I need to subtract 1? Minus n plus I don't actually, do I? Okay, okay. So I did a little mathematical error there. Okay, so let's see. So if I is 0, I'm trying to think about this example again. Okay, so I want to compare this number to this number. So this number is at 0, and this number is at 3, 4, is at 5. And so 5 is equal to, 5 is equal to nums.length minus n plus I. Yeah, I don't need to do minus 1 as well. Okay, bit of a mathematical error on my part. But yeah, that is how we could do this problem here. All right, so yeah, so not much code, but we had to think a bit to get to it. Okay, there we go. Okay, so if the array contains somewhere 3 increasing adjacent numbers, go ahead and pause and try this. Okay, so you can probably guess how I'm going to do it. I'm going to stop 2 before the end and basically say if it is there starting at index I3 in increasing numbers. And yes, it does say increasing, so they can't be equal. So if nums I is less than the one next to it, and nums I plus 1 is less than nums I plus 2, so I have now found a series of 3 increasing adjacent numbers, then I return true. Otherwise, just false. Okay, what have I done? Can I not read? let's see. Oh, okay. This question is worded terribly. This, if we're following the directions of the problem, this case should be true. Okay, so wait. Does it mean? Okay, wait. Sorry, the instructions are just not clear here. Okay, so 1, 2, 4 is a series of three increasing numbers. If by adjacent, it's talking about adjacent in numerical value, so like the numbers have to be one away from each other, then I could see what it's talking about. But I interpreted this adjacent as just meaning they're adjacent in the array, which I think is the more reasonable interpretation. But okay, so the instructions are not clear, is what I have to say about this. So what it really was asking, is there like a series of three numbers that just increase by one each time? So if nums I plus 1 is the next number, and nums I plus 1 on the outside is the number after that, then we have found what we want to find. Okay, so perhaps could have been worded a bit better. Okay, given start and end numbers, return a new array containing this sequence of integers from start up to but not including end. Okay, go ahead and pause and try this. All right, let's do it. So my result array, I'm going to call it r, or yeah, actually we'll do nums equals an int array. And so the length of this array, let's think about it. So this array, this range, if we subtract the second number minus the first, we get 5, and we see that 5 is the length of the array. So the size of the array is going to be end minus start. And then all we need to do is for each index in our array, I less than nums.length, I plus plus. So the number at each index is going to be equal to I plus start. So nums I is going to be equal to I plus start. If you want to pause and think about that, you can. But that is going to be how we do this here. There is also a way to do this using int stream. So another way is like so. Okay, so we could also do it like that. Return an array that is left shifted by 1. So 6253 returns 2536. So you may remember actually that a long time ago, well maybe not, I don't know how long ago, but it is for you, but we did a problem where we had to rotate an array left 1, but we were guaranteed that array had length 3. Now we're not guaranteed that that array has length 3. We just need to rotate it left, and it could be any length. So that's what you're doing here. Go ahead and pause and try this. Okay, so here's what I'm going to do. So I'm going to basically shift everything left, and when I shift everything left, I'm going to basically copy this number and move it one left. Copy this number and move it one left. Copy this number and move it one left. But notice that when I copy this number and I move it one left, I'm obliterating this 6. Like I'm making it, like I'm deleting it. I'm overwriting it. So what I'm going to do is I'm going to keep track of the first number. I'm going to say int first is equal to nums I, so that I keep track of the first number, so that when I overwrite it, I don't lose it. And then in order to shift everything left, I'm just going to say I'm going to start at index 1 and go to nums. Actually, start at I equals 0, stop 1 before the end, and then just say nums I, set each index to the next index, and that'll shift everything left. Okay, and then all I need to do is set the last index to whatever used to be first, because you see how that's what happens in all these examples, right? This 6 that was at the beginning now goes to the end. So I need to set the last number, which is going to be at nums.length minus 1 to whatever the first number used to be. And yeah, first is going to be at nums0, sorry. And okay, we have to return the array back. All right, and let's see. We just need to make sure we handle the possibility of an empty array. So if nums.length is 0, return nums. I know nums is empty, so I can just return it. Okay, there you go. That's how we could do this one. Okay, For each multiple of 10 in the given array, change all the values following it to be that multiple of 10 until encountering another multiple of 10. Okay, go ahead and pause and try this. Okay, so yeah, I think the examples here make it very clear. So yeah, we find a multiple of 10 and we just set everything to that number till the next multiple of 10, then set everything to that number and just keep going. Okay, so what I'm gonna do is I'm gonna have like a current multiple, like a number that's gonna be the current multiple of 10 that I'm filling with, right? So like once I'm like here, the current multiple of 10 becomes 10, and so I just set everything to 10 until I find another number that's a multiple of 10, and so now the current multiple of 10 is 20, and I'm setting everything to 20. So I'll call it cur, and so I'll set the default value of cur to be 1, and I'm doing 1 because I know 1 is not a multiple of 10. So I know that if cur equals 1, then I have not found a multiple of 10 yet. So what I'm going to do is I'm going to go through my array, and I'm going to say, first of all, if the element here is a multiple of 10, so remainder 10 is 0. If this number is a multiple of 10, then I set cur equal to this number. And then otherwise, if it's not a multiple of 10, then I say if the current multiple of 10 is 1, then just don't do anything. So I'm actually going to just not putting there. But if the current multiple of 10 is not 1, then I need to set I to the current multiple of 10, and then I can return the array. And that's how we could do that one. I could rewrite this as this here with omitting those curly braces, and I could actually put this on the same line, and this is generally the style if you have like an else if, is to write it like this. And I can omit those, and it's looking great. Okay, so that's how we could do this one. And maybe -1 is a more reasonable value because -1 is even clearer that like that's an error condition, because some methods, as you know, index of returns -1 to signify that you have not found the value you were looking for. Okay, pre-4, given a non-empty array of ints, return a new array containing the elements from the original array that come before the first 4 in the original array. The original array will contain at least one 4. Okay, go ahead and pause and try this. Okay, so here is what we'll do. So I just want to find the index of the first 4. That's my goal to start off. So index, I'll call it index 4. And I'll make it equal -1 by default. And I know that there's guaranteed to be at least one 4 in the array. So I'm just going to go through my array. So yeah, just go through it and say, if I find a 4, index 4 equals I. And I actually want to break, so I want to say index 4 equals I, and then break. We talked about this earlier. Break, and okay, so that will give me the index of the first 4 in the array. And so now what I want to do is I want to return a new array that contains the elements from the beginning of the array to that index, to index 4. And so I could create a new array, and that new array would be like int array r contains an int array of length index 4, and then I could copy things over. So that would be like 4 int I equals 0, I less than index 4, I plus plus. Ri is going to equal whatever nums had at that index, and then I return the array. And so that's how I could do that one. Now, this last step, there is an easier way to do this. So there's a method called, in the arrays class, called copyOfRange. So, and what it does is it you pass in an array, a range of values and an array, and it'll give you a copy of that array from that range. It's sort of like a subarray, if you can imagine like a substring, like how we know about substrings. This is like a subarray of the array, which we can do. So we're just going to do arrays.copyOfRange. We're going to pass my nums array and go from index 0 to index 4. So this is an alternative way to do it that is more concise. Yeah, so that's how we could do this. There unfortunately is no index of method for arrays. I know, it's kind of sad because as you can see, we do kind of need to use it fairly often. But yeah, that is how we could do this one. Given a non-empty array of ins, return a new array containing the elements from the original array that come after the last 4 in the array. The original array will contain at least one 4. Okay, so this is basically identical to the last one, pretty much. Go ahead and pause and try this. Alright, so you'll never guess how I am going to solve this one. Just going to loop backwards, starting from the end of the array. -1 greater than or equal to 0. I'm going to say if nums I is a 4, then we've found our 4. We are guaranteed to have at least one 4. And the array is not empty. Okay, so and then all I need to do is arrays.copy of range. And then the range here is going to be nums.length minus last 4. Let's see, actually no. We want to start at last 4 and go to the end of the array. Yeah, okay. And that will not do that one because we have an array out of bounds exception. Okay, so let's see. The last 4, sorry, the last 4 should not equal -1. Last 4 should equal I. Okay. And actually, because the last 4 is going to be the index of the 4, and we want everything after the 4, we need to add 1. Alright. Okay, so an element in the array is alone if there are values before and after it, and those values are different from it. Return a version of the given array where every instance of the given value, which is alone, of a given value which is alone, is replaced by whichever value to its right, left or right is larger. Sorry, I'm trying to read really fast, and I'm kind of failing. Okay, so go ahead and pause and try this. Alright, so every element should be the whichever is larger out of its left or right. So, okay, so not every element. Every element that's alone should be the larger of its left or right. So, yeah, okay. Okay, so we're just gonna go through the array, and let's see. So we already know that okay, so well actually no. It says an element's only alone if there are values before and after it. So I don't even care about the endpoints. So I'm actually going to start at index 1 and go to nums.length -1. So I'm only looking at um, the interior numbers in the array, the numbers that are not on the edges, on the first or last indices. Okay. And then if the number before it, so well first of all, if it's not equal to the number before it, it's not equal to the number before it, and it's not equal to the number ahead of it, then it is going to going to be equal to the maximum of those two numbers. Okay. Yeah, so no, sorry, not an and there. My brain's kind of going on autopilot, my bad. Okay, so then we can return nums. Okay, and then let's see, so okay, so let's see, so we'll say that an element in an array is alone if there are values before and after it, and those values are different from it. Okay, return a version of the given array where every instance of the given value which is alone. Oh, okay. So okay, only of the given value which is alone. Okay, so I really should learn how to read, because I clearly don't know how to. Okay, there we go. So, reading, good idea. Okay, return an array that contains the exact same numbers as the given array, but rearranged so that all the zeros are grouped at the start of the array. The order of the non-zero numbers does not matter. So, okay, pause and try this one. Okay, so one thing I'd like to point out is that if the order of the non-zero numbers does not matter, then the non-zero numbers must all be the same. You can think about that for a second, right? If you move all the zeros to the front, and the author is saying, the problem author is saying that um, the order of the non-zero numbers doesn't matter, then those numbers must be the same. Because if they're different, then the order would matter because there's only one right answer to these test cases. So that's one thing you can think of, sort of kind of reverse engineering the problem. But yeah, so let's think about how we can do this. So we can modify the given array or return a new one. Um, so let's see here. So what I'm going to do is, because I know the order doesn't matter, I'm going to count up the number of zeros there are in the array, and I'm going to create a new array where I just have that many zeros at the front, and then I put all the other numbers in nums. Um, yeah, I put all the other numbers in nums in my new array. So I'm first going to get the zero count, so get number of zeros in the array. So I'm going to say zero count enter nums, and then just say get the count here. You've probably seen this code like a dozen times now, which is good because it's common code. If this number is 0, increment the count, return the count. Wonderful. Okay, so now you have the 0 count. So I'm just going to get it up here. 0 count, 0. Okay, 0 count equals the 0 count. Okay. So remember, this is the variable. This is a variable. This is a method. They're not going to conflict. The names are not going to conflict. Okay, so now we have the number of zeros in the array. And so here is what I'm going to do. So I'm going to create a new array. And it's going to have the same length as my nums array. So same as nums.length. And I need to spell that right, nums.length. And so I know by default, by the way, that in an int array, all the numbers are 0 by default. So I don't need to bother filling up the first 0 count numbers with 0. The only reason I need the 0 count is I need to know where to start putting in the non-zero values from nums. So what I'm going to do is I'm going to say, this part's going to get a little complicated. I'm going to have basically two indices going on here. So let's see here. So what I'm going to do is I'm going to create an index. It's going to be called rIndex. It's going to start at 0 count because that's the index of the first non-zero number in R that I'm going to start placing numbers at. And I'm going to just make an int. Sorry, I'm just going to make a for loop that's going to go through my nums array. And what I'm going to do is I'm going to say if this number is not 0. So if this number is not 0, then I need to put it into my array. So what I'm going to do is I'm going to say r at the current index in my array. So not at I, but at the current index in R, I need to set this equal to nums I and then increment my r index, right? And so I only increment my r index whenever I add a new element into R, when I basically place in a new element from nums into R. And then I return R when I'm done. And on line 5, we are having some problems because I did not put I less than. And there we go. That is how we could solve this one. And now I want to think real quick if there is a different way to do this. Well, of course there's a different way to do this, but a different way that I want to show you. And I think there is. So, okay, I'm going to go ahead and do that. So I'm just going to comment this whole thing out, including my helper method. I'm going to comment it all out. And I wonder what happens if I press go now. It's like it can't even find it. Okay. So I'm just going to start again from scratch. So my idea is I'm going to go through the array, and whenever I find a 0, I'm going to basically keep an index, an outside index, kind of like our index. That's going to be the where I'm like moving zeros to in my array. So whenever I find a 0 in nums, I'm going to swap it with whatever's at my index, my separate outside index. And then I'm going to increment that separate outside index by 1. Then I'm going to keep looping through. Oh, I find another 0, move it, shift it at the beginning, like swap it towards the beginning. Find another 0, swap it towards the beginning, until I've effectively swapped every 0 so that the zeros all come first. So I'll call it the 0 index, and I'll start at 0. And then what I'll do is I'll go through my array, less than nums.length, I++, and I'm going to say if this number here at I is 0, then I'm going to basically swap I with 0 index, swap the element at I with the element at 0 index. So if you want to swap things, we've talked about this before, I can do it like this, equals nums 0 index, nums 0 index, index equals temp, and then I want to increment the 0 index, and then return the array. Yeah. Okay, so that's another way to do it, a bit more concise. Yeah, so we did not really take advantage of the fact that we know all the other numbers must be the same, but you can look at the test cases and see that that is true. But perhaps, I just told you that because perhaps, you wanted to take advantage of that in your solution. But yeah, so that is another way of doing this one. Okay, so return a version of the given array where all the tens have been removed. The remaining elements shift left towards the start of the array as needed, and the empty spaces at the end of the array should be 0. Okay, go ahead and pause and try this one. Okay, so I actually had to have a longer pause because I was actually thinking about it as well. Okay, so what I'm going to do is I'm actually going to make a new array because I think that's easier in this case. So this new array, it's going to be called R. It's going to have the same length as nums. And then I'm going to also have an R index. And I'm going to basically place in the numbers from nums into R, but only when they're not a 10. So for each number in nums, if this number is not 10, then I'm going to put it into R. So R at R index is going to equal 0. Sorry, not 0, nums I, and then I increment the R index. And I know that all the remaining values in R will be 0 because they'll have the default value. So I'm actually done. I can just return R here. So yeah, that's how we could do this one here. Return a version of the given array where each 0 value in the array is replaced by the largest odd value to the right of the 0 in the array. There's no odd value to the right. Leave the 0 as a 0. Okay, so go ahead and pause and try this. Okay, so this is the kind of problem where efficiency is something that you might be concerned about, because there's an efficient way to do this that's a little more complicated, and there's just a sort of intuitive and kind of just simple way to do it that that's not as complicated to code. So I'll show you the simple way, and I'm not even going to show you the more efficient way because CodingBat is not a place where you should be concerned with efficiency, pretty much. So yeah, CodingBat's just to help you learn to code, get the rudiments, the fundamentals down, and then, if you pursue other coding, you can talk about efficiency. So what I'm going to do, my strategy is whenever I find a 0, I'm going to have a helper method that you pass in nums and you pass in index, and it gives you the largest odd number after that index. So I'll call it largest odd. Odd takes an int array nums and an int in, and basically I want the largest odd number after in, so I'm going to say for int I equals n plus 1, because I want to start after the largest number after n. I less than nums length I plus plus. I'm going to say I'm going to say the max equals 0, and I can do this safely because I know that 0 is not an odd number, so that's fine. So basically, if this number is odd, nums I remainder 2 equals does not equal 0. If this number is odd, then max is going to equal the maximum value of its current value and nums I. And then at the end, I'm going to say basically what I want to do is if I don't find any odds, I want to return 0 because I want to leave that 0 as a 0. So I'm actually going to be okay with this, and I'm just going to return max, even though max might be 0. And all I need to do is say for each number in my array, if this number is a 0, it is going to be equal now the largest odd after it. Odd nums in, and then just return nums. And that's how we can write a code that doesn't compile. There we go. Okay, so that's how we could do that one. Okay, so return an array that contains the exact same numbers as the given array, but rearranged so that all even numbers come before all the odd numbers. Other than that, the numbers can be in any order. You can think about what this implies if you want to. Okay, pause and try this one. Okay, so of course the fact that the numbers can be in any order implies that all the evens must be the same, all the odds must be the same. So the array can contain a maximum of two different kinds of numbers, an even and an odd. So yeah, only two different numbers can be in the array. Yeah. So maybe you want to write a solution that takes advantage of that fact. Okay, so let's see how we could do this. I'm going to go with the swapping strategy that I talked about on the other problem. So I'm going to go through the array, and I'm going to, whenever I find, let's say evens come before odds, right? Yeah. So whenever I find an odd number, I'm going to swap it with my even index. Like how in the other problem I had a 0 index, I'm now going to have an even index. And whenever I find an odd, I'm going to swap it with the thing at the even index, and then increment the even index. So for int I equals 0 to the end of the array, we can I can basically say if this number is odd, if we find an odd number, then swap it. Actually, no, sorry. If we find an even number, okay, sorry. So let's see. So wait. So if this number is even, we want to swap it with the even index because we want the evens to come first. So if it's even, we want to swap it down so it comes earlier. Yeah, that makes sense. Okay, so if this number is even, then we swap it with even index. So temp equals nums I. We know how to do swapping. Nums I equals nums even index. Nums even index equals temp. And then, of course, increment the even index. And then we can return the array. And that's how we could do this one. Another solution, I won't code it, but I'll tell you it audibly. I'll articulate it. So another idea would be to take advantage of the fact that all evens and all odds must be the same. So you could basically say, you basically count up the number of even numbers in the array, and then figure out what is the one even, like the one single even number that the array contains, and then just return a new array where you put, that many even numbers followed by, and then fill the rest with whatever the odd number is. You'd have to do some special cases there, because like what if it only contains even numbers? What if it only contains odd numbers? How do you handle that? But that's another solution you might try. Okay, last one in this section. This is a slightly different, sorry, this is slightly more difficult. This is slightly more difficult version. Okay, sorry. Okay, so I'm not the one with the English problem this time. This time. Okay, so this is a slightly more difficult version of the famous fizzBuzz problem, which is sometimes given as a first problem for job interviews. I wish job interview questions were this easy. They are definitely not this easy. Just this website was made a while ago. Let's say they're not this easy anymore. Okay. Consider the series of numbers beginning at start and running up to but not including end. And so, for example, start equals 1 and end equals 5 gives the series 1, 2, 3, 4. Return a new string array, return a new string array containing the string form of these numbers, except for multiples of 3, use fizz. Instead of the number, for multiples of 5, use buzz, and for multiples of both 3 and 5, use fizzBuzz. In Java, okay, you know that. This version is a little more complicated. Yes, 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 yes. Okay, so go ahead and pause and try this. All right, let's do this one, the final one. Okay, so here's what we'll do. So my resulting string array, as we talked about in the other fizzBuzz problem, its length will be, I'll call it r, its length will be int minus start. And then for each index I in the array, what we're going to do is we are going to say, so this value should have, I plus start. So I'll just call that value in. I plus start is going to be in. So this is what we want, what should go at this index in R. But if it's divisible of 3, multiple. If it's a multiple of 3, use fizz, 5, buzz, etc. So if in is a multiple of 3, actually what we want to do is I'll actually say I'll actually use Boolean. So I'll say if it's divisible by 3, I want to use fizz. So I'll put f. So f is if in is divisible by 3, and b for buzz is if f is divisible by, in is divisible by 5. We're getting into some, we're getting a lot of variables here, but basically, if f and b, then r at index I should be fizzBuzz. Otherwise, if just f is true, then r at index I should be fizz. Otherwise, if just b is true, then r at index I should be buzz. And then otherwise, r at index I should be string dot value of in. So that is how we could do that one. Yeah. All right. So that is the Array-2 section on CodingBat. I know I really sped through that one. But yeah, a lot of the problems pretty straightforward, making count variables. Towards the end, though, they got a bit interesting, so that was fun. But yeah, going back to the home page, looks like we have an Array-3 section as well. All right, a nice group of 9 problems. All right, we'll do that next time, though, so I will see you then.